Good afternoon, everyone. This is the pre-launch news conference for the GRAIL launch. Coming up on Thursday aboard a United Launch Alliance Delta II rocket. And here to talk about the mission and our upcoming launch is Ed Weiler, the Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington. Tim Dunn, the NASA Launch Director from NASA's Kennedy Space Center here at Cape Canaveral. Vern Thorp, the Program Manager for NASA missions from United Launch Alliance, Denver. David Lehman, the GRAIL Project Manager from the Jet Propulsion Laboratory in Pasadena. John Henk, the GRAIL Program Manager from Lockheed Martin Space Systems in Denver. And Joel Tumbíolo, the Launch Weather Officer from the 45th Weather Squadron at Cape Canaveral Air Force Station. And we'll begin first with comments from Ed Weiler. Ed?
Thank you, George. Good afternoon, everybody. This has truly been an incredible year for space science at NASA. Over the course of a year, we've had 2 successful flybys of comets this fall and winter. We went into orbit around Mercury with Messenger. Aquarius, an Earth-observing satellite that will do both climate and weather, was launched in June successfully. Dawn went into orbit around Vesta in July. Juno was launched in August. We're going to talk about GRAIL today, which hopefully will be launched on Thursday, weather permitting. And then following up with the MPOS preparatory mission, which will be launched in October from Vandenberg, and the big one, MSL, Mars Science Lab, we plan to launch just after Thanksgiving. And it'll be the largest rover ever sent to Mars to determine whether Mars was ever an abode for life. Getting back to GRAIL, first, congrats to Maria Zuber, her MIT team, contractors, JPL, for delivering GRAIL to the launch pad. On schedule and actually slightly below cost. So just like Juno, it's the second mission in a row that's got here now on cost and schedule. GRAIL, simply put, is a journey to the center of the moon. It will probe the interior of the moon and map its gravity field 100 to 1,000 times better than ever before. We will learn more about the interior of the moon with GRAIL than all previous lunar missions combined. For those of you who are old enough to remember some of these things I'm going to talk about, we crashed into the surface of the moon with Ranger several times. We landed on the moon several times with Surveyor and scratched its surface. Lunar orbiters photographed its surface. And then, of course, with Apollo, humans walked on the surface and drove dune buggies across the surface. But GRAIL is the first mission to look below that surface. And how will it do that? It's actually 2 small satellites that will fly in tandem about 200 kilometers apart, about 50 kilometers high. The satellites will monitor the distance between each other, and as the first satellite goes over a higher mass concentration or higher gravity, it will speed up slightly, and that'll increase the distance. And then as the second satellite goes over, that distance will close again. That's how it actually maps the gravitational field of the moon, and it will do that over the course of 3 months, and it'll do a complete map 3 times over those 3 months. Let's see. I won't go much more into the science of GRAIL because I don't want to take Professor Zuber's wind out of her sails tomorrow. She'll be talking to you at 10 o'clock, in-depth science presentation. I want to close by doing a commercial for an LRO press conference that just finished around noon today. LRO is a lunar orbiter, and it normally operates at about 31 miles. Over the course of the past few months, we dropped it to 13 miles above the moon's surface. That's about 70,000 feet. For those of you who know airplanes, that's about the height of a Global Hawk. I seen the pictures last week, the stills. They also mapped Apollo 12, 14, and 17's landing sites. For those of you as old as I am, you may remember how fun that was to watch those missions in real time on TV. I urge you to go to nasa.gov to look at those images because they might bring some of that thrill of exploration from your youth back to you. Really, really awesome images. Thank you.
Thank you, Ed. And now to Tim Dunn, the launch director from NASA's Launch Services Program here at Kennedy. Tim.
Thank you, George. I'm proud to be here today representing all the men and women of NASA's Launch Services Program. GRAIL is my first mission as a NASA launch manager, and I'm pleased to begin with a Delta II launched spacecraft heading back to the moon to do some extraordinary science. GRAIL is currently the last contracted Delta II mission to be launched from Complex 17, and it will be the 356th overall Delta to be launched. Complex 17 at the Cape has a proud heritage of hosting 258 of those 355 total Delta launches to date. Over the past week for the GRAIL mission, the combined NASA and United Launch Alliance team has held the flight readiness review. We assessed preparations of the rocket, the spacecraft, the range, and facility infrastructure, that it was ready to proceed with tanking of the second stage. We then performed mission dress rehearsal last Thursday with a successful conclusion and loaded hypergolic propellants on the second stage on Friday. Our entire launch team was able to benefit from a busy week last week by taking the entire 3-day weekend off, which we really needed and much appreciated. This morning we held a successful launch readiness review, and we did receive concurrence from NASA management as well as spacecraft, launch vehicle, and range agencies to proceed into countdown. I'd like to show a video of the buildup of the GRAIL Delta II Heavy video processing at Complex 17. Can we roll that? Here you see the first stage booster coming out to Complex 17B on the morning of 7 April of this year. That's the power plant at the back of the first stage, the RS-27A. Nice decal as we get ready to erect into our mobile service tower. You're going to see a quick sequence of this erection activity as we use the MST here as a mobile crane and lift it in place onto the launch mount. Nice view of the Cape Canaveral Lighthouse in the distance just north of Complex 17. So here we are on the morning of April 25th, bringing out the solids for the mission. A Delta II Heavy has 9 GEM 46 solids manufactured by ATK. So that erection sequence proceeds using the same mobile service tower as a mobile crane to bring those solids in close to the vehicle. You see the ball and socket attach points there. This is the morning of May 10th, bringing out the second stage. You see the second stage going up the side of the of Complex 17. And here we fast forwarded to the morning of August 18th, where we brought out the GRAIL spacecraft in the transportation can. This is the spacecraft transportation can being lowered down onto the second stage. Just a quick shot of the fairings. And there's a nice shot of both the GRAIL A and B spacecraft at Complex 17. The next sequence you're going to see is the payload fairings being brought in around the spacecraft, and we did this in anticipation of Hurricane Irene. We actually moved up this processing about a day and a half so that we could be all buttoned up and safe and secure in advance of the hurricane. And you'll see there the payload fairing closeout. Our fairings manufactured in Iuka, Mississippi by ATK. And we are now fully built up and buttoned up and ready to go. Just wanted to let you know today at Complex 17, we did our final range safety beacon checks. We did our final pre-launch slewing of the engines and our final azimuth update. All of those tests went well. Wednesday evening, tomorrow evening, we'll begin our final major pre-launch activities out at Complex 17, where we will roll the MST into the launch position. That will happen about 8 p.m. tomorrow evening. The launch team is going to arrive on console about 4 a.m. on Thursday morning, and we will then begin final preparations of the vehicle. We'll turn power on about 5:30. About 6 a.m. we'll begin pressurization sequence, followed by loading of the first stage RP1 fuel. And then at about 7 a.m. we'll begin loading first stage liquid oxidizer. Those will then proceed into final engine slewing and be ready to launch. for our first opportunity on Thursday of 8:37 and 06 seconds Eastern Time. And that completes the build-up sequence and what we have remaining to do prior to launch on Thursday. Back to you, George.
Thank you, Tim. We'll hear now from Vern Thorp, the Program Manager for NASA Missions from United Launch Alliance. Vern.
Hey, thank you, George. Good afternoon. I'm here on behalf of Michael Gass, our President and Chief Executive Officer at ULA, and the 3,700 men and women of ULA. We're very proud once again to be supporting NASA as we launch GRAIL, which is the third of 5 missions that ULA is launching for NASA this year. This launch also marks the 9th flight for ULA in 2011, the 49th Delta II mission for NASA, and our 3rd launch for NASA in just 3 months. The ULA team has worked very closely with our NASA partners for the last few years to get us to this point. It's always wonderful to be part of one of these mission teams and to work side by side with such a capable and dedicated group of professionals. We're ready to launch the GRAIL spacecraft, sending it on its way to produce the gravity map that you heard about and allowing us to peer into the moon's interior. GRAIL will be launched aboard a Delta II Heavy. It's a ULA vehicle featuring a first stage booster powered by a Pratt & Whitney Rocketdyne RS-27A main engine. We'll also have 9 Alliant Tech System strap-on solid rocket motors on this mission as well. An Aerojet AJ-10 engine will power the 2nd stage, and until we get out of the atmosphere, the payload will be protected by a 10-foot diameter composite payload fairing. And you heard Tim summarize the activities that take us down to T0 tomorrow morning. I'd like to pick up the story starting at T0, so if we could roll the video, the animation. Okay, we'll lift off with a combined thrust of about 1.3 million pounds from 6 of the SRBs and the main engine on the core stage. First major event you'll see is when the 6 ground-lit SRBs burn out. We'll light the 3 air-lit SRBs, jettison the 6 ground-lit SRBs about 80 seconds into flight. The air-lit SRBs will burn for another 80 seconds, and 160 seconds into flight, they'll burn out and be jettisoned. That core stage will continue to burn until we run out of propellant. That'll happen about 4 minutes and 23 seconds into flight. At that time, we'll jettison that first stage from the upper stage, and we'll begin the first of several engine burns. That first burn will last about 2.5 minutes, and shortly into it, we'll jettison the payload fairing. After that 2.5 minute engine burn is complete, we'll enter a parking orbit coast for about an hour. At the end of that coast, we'll be in the proper position for doing our 2nd engine burn. That'll be a 4.5 minute burn. And when that burn is complete, we will have placed the spacecraft into the translunar trajectory that they need to be in. Over the next 20 minutes, we'll reorient the upper stage. We'll separate both of those spacecraft about 10 minutes apart, and then we'll perform a series of maneuvers with the upper stage to move it safely away from the spacecraft as they continue their mission. We'll actually do, it's not shown here, but we'll actually do a 3rd short engine burn with the upper stage, and it'll place the upper stage safely out of the way in an orbit between the Earth and Mars. We're proud to support NASA's science missions, playing a critical role by delivering these one-of-a-kind spacecraft in support of the global science community. This mission represents the culmination of years of hard work by NASA, Lockheed Martin's spacecraft team, and our ULA launch team. We anticipate that our Delta II vehicle will perform exceptionally well, placing GRAIL on an accurate translunar trajectory, which will allow our scientists to study the structure of the lunar interior from crust to core and to advance our understanding of the thermal evolution of the moon. As this is the last currently contracted launch from Space Complex 17, we'd like to reflect on the tremendous historical significance that this complex has had and on the impact of the military and the scientific missions that began their missions from Complex 17. Those would include the global positioning satellites, all the way up through GPS 21, the last Block 2R mission. We launch for the Air Force, and they're used by people all around the world. And there's a lot of other very famous science missions that launch from this complex as well, most notably the Spirit and Opportunity rovers that flew on Delta II from that complex. So overall, this complex has seen 258 Delta launches to date. 109 of those have been Delta II. GRAIL will be the 110th Delta II launching from that complex. And I'd like to once again thank all of our mission partners who've worked with us tirelessly to make this mission a success. George, I'll turn it back to you.
Thank you, Vern. Next to the GRAIL project manager, David Lehman from the Jet Propulsion Laboratory. David?
Oh, thank you, George. Good afternoon, everybody. GRAIL was chosen as a Discovery class mission in December 2007, and a lot of things had to come together to make this mission happen. Our principal investigator, Professor Maria Zuber from MIT, she put together the science team. And then in addition to that, at JPL is where we do the project management. The instrument was built at JPL, and also the mission operations lead is at JPL. And then finally, the spacecraft is built at Lockheed Martin in Denver, and they also perform the day-to-day operations of the spacecraft. So I'd like to go to the first image, please. In this image, we show what will happen after launch, and here's the second stage with the fairing being deployed, and we're getting ready to deploy the two spacecraft GRAIL A. So the second stage is maneuvered to the correct position, and here we deploy a GRAIL A spacecraft, and this happens about about an hour and a half after launch, and then within a few seconds after that, about 5 seconds, is when the transmitter's turned on, and then about 5 minutes later is when we expect to acquire the signal from the Deep Space Network. And then about 8 minutes after the GRAIL A is deployed, then the GRAIL B spacecraft are deployed. And if we launch on September 8th, it'll take GRAIL about 3.5 months to make the voyage from the Earth to the Moon. And here, this next image, I want to show you what this trajectory looks like. On the left shows the trajectory if we launch on September 8th. And then we go all the way out to the L1 point. This is where the gravity is balanced between the Earth, the Moon, and the Sun. And we do about 5 maneuvers in order to get the spacecraft into the correct orbit at Mars. But if we launch at the end of the launch period, which is about 31 days later, the middle curve shows the trajectory we go through to get to the Moon. But regardless of when we launch, the two spacecraft arrive at the Moon on the same day. GRAIL A will arrive on New Year's Eve this year, and then GRAIL B the next day on New Year's Day. And in the next image, I want to show you what will be happening. What will happen is the spacecraft will do about a 35-minute burn each one, and then the next day the other spacecraft will do maneuver. And these are approached from the south pole of the Moon. And then what we do is we do a series of intricate maneuvers with the two spacecraft over the next 3 months, and our goal here is to circularize the orbit rather, in order to put them in an orbit around 55 kilometers above the Moon. And then once we're there, the spacecraft, they're on a one-way mission, but what I want to talk about next is how do we get that data back. And in the next animation, you'll see the two spacecraft communicating with each other. They're sending back K-band ranging signals, also exchanging clocks between each other, and then they're downlinking health and status data from the two spacecraft, and then finally sending down navigation data for the scientists. So that summarizes the GRAIL mission, and I want to turn it back to you, George.
All right, thank you, David. We'll go now to the GRAIL program manager from Lockheed Martin Space Systems, John Henk. John.
Well, thank you, George. Good afternoon, everyone. Let me start by just welcoming you to the GRAIL team. I want you to join the team a minute and just go over a little bit of the processing that we've seen here at the launch site since the spacecraft arrived at the end of May this year. Can we go to the first video, please? We arrived here on the 20th of May on the C-17. Both spacecraft were carried together in the spacecraft shipping container, the one that actually was used to bring Juno down. Shipping container was then moved over to the Astrotech facility, where we did the standalone spacecraft processing. Took it out of the container, then went through a full series of arrival tests to make sure that everything was good, and processed both vehicles in parallel, similar to what we have done throughout the spacecraft assembly and test period of time. Went through a number of operations, including a final space or solar array deploy activity on the turnover fixtures, illumination testing, final software load and testing, and then brought both vehicles from the normal processing facility, Building 1 there, over to the hazardous processing facility for propellant loading, pressurization, and the start of integration with the launch vehicle. We then assembled it into its launch configuration. And then, unlike an Atlas, which would actually encapsulate in that facility, the Delta II actually encapsulates at the launch pad. So we go through a process called canning to actually get it into its transport configuration over to SLC-17. And from what you saw in the video before, you saw a lot of the on-pad integration of the spacecraft onto the launch vehicle. Ending configuration, as you can see here displayed, the two vehicles sitting on their flat plate adapter married to the second stage of the Delta II. The first part of encapsulation is actually started here with the back clamshell actually attached in that configuration. So it gives you a good shot of what the vehicle and the spacecraft look like integrated there. Leaving it there for a minute, what I'd like to be able to do is, okay, you've heard from the launch vehicle what happens in the next 2 days here as we get up to launch and then through launch. For the spacecraft, we actually start about 24 hours prior to launch with our final power up. And again, our configuration for the spacecraft is that you cannot turn it off once it's in its final configuration, so there's not an on-off switch. We do that through enable plugs. So 24 hours before they start closing out the launch complex and preparing for launch, we'll actually go in, power up, do functional testing, install the battery main enable plug and the pyro main enable plugs that put us into our flight configuration. And from that point on, we stay powered up for the rest of the mission. Approximately 4 hours prior to launch, we'll start into the terminal count. As you can see at this point in time, the main show is going to be the launch vehicle. The spacecraft has already proven to be good to go. And therefore, we'll take the ride on the Delta II through separation. A couple things we'd like to go over right now. One of the most common questions often asked with the GRAIL spacecraft, and I'll use models as an indication here, is the makeup of the vehicles themselves tends to bring heritage from several prior programs. The body of the spacecraft pretty much comes from an experimental satellite program with the propulsion. The avionics internal to it comes to us from Mars Reconnaissance Orbiter. So a lot of the avionics itself would actually come from that particular area. The science for the KE band ranging system actually comes from the GRACE program, which is a German pair of satellites flying NASA science mission. In terms of how this actually works, it's fairly straightforward with respect to how do you gauge the distance between the two vehicles during the mission itself. Understand that the distances that we're actually trying to measure between these two spacecraft, when they go into a formation, the formation is lead trailed by the second one, actually about 75 miles to 225 miles apart. But what we're trying to measure is the width of less than a human hair. So you're trying to get very, very precise measurements from the two vehicles. The simple way to do it here is with the KA band system. How do you measure distance? You use a ruler. So in other words, our ruler is really the KA band signal between the spacecraft. And understand that in the KA band range for an RF frequency, you're talking billions of cycles per second. So those are very precise and can be measured. Then, so you have the KA band signal from the antennas. You get the measurement from the antennas, distance between the two of them. You have a time transfer system that then hacks and can actually show you the timing associated with it. So you get measurement of distance with the time, and then you're able to range with the DSN station. You get precise measurements there. So it's a very straightforward, very simple way of gaining the science. Quite a bit of math, though, associated with being able to take that and translate that into seeing the changes between them, where they are in the moon, and determining the gravity map from the two. But anyway, for those of us that have difficulty understanding this thing, that's a little bit more straightforward with the two vehicles. Anyway, back to you, George.
Thank you, John. We'll look now at the weather for Thursday morning. Joel Tumbíolo is our launch weather officer from the 45th Weather Squadron at Cape Canaveral Air Force Station. Joel.
Thank you, George, and good afternoon, everyone. As usually is the case during the late summer, early fall-like season, weather is always an issue regardless what the mission is, and this mission is no different. If I could have the satellite picture up on one of the screens up there, I could use that to aid in my discussion. Basically, we have a feed of moisture that's stretching all the way from southwestern Gulf of Mexico all the way through the state of Florida, all the way to what was Tropical Storm Lee, which made landfall over Louisiana a couple days ago. Well, the center of circulation is right now over northern Georgia, but extending south and southwestward from that center of low pressure is a low pressure trough or a front that is right now located over western Florida into the eastern Gulf of Mexico. And that front will be slowly moving eastward over the next couple of days, and basically will be sitting right over central Florida over the next couple of days. So we're going to have that instability of a stationary front over the area, and in addition to that, we're going to have a large plume of tropical moisture feeding in from the southwest. So basically what we're looking at is conditions like we had right now. We're going to be looking at afternoon showers and thunderstorms, mainly during the late afternoon and early evening hours. That would be more of an issue for the tower roll, as we are forecasting about a 60% chance of having lightning within 5 nautical miles in the area at the time tower roll is scheduled to almost begin. Assuming we get through that, then the thunderstorms will die out after midnight, and then once we get into the early morning hours into the terminal count, the issues that we're going to be looking at is for thunderstorms developing not over the land of Florida per se, but over the eastern Gulf of Mexico and over the Gulf Stream to our east. So we're going to be sandwiched in between probably two areas of thunderstorms. And what we're going to be monitoring is thunderstorms that are to our west and the anvil clouds from those thunderstorms moving towards the east. And we'll be looking at the anvil cloud rule as far as that's concerned. So that's pretty much basically the setup. Right now, the forecast for beginning of the launch window is a 60% chance of violation, with the two main concerns being the anvil cloud rule, again, thunderstorms to our west during the early morning hours over the eastern Gulf of Mexico, and the upper level winds are such that those anvils could be coming in our direction, and also some local cumulus clouds and showers that could develop during the early morning hours, although typically, like I said, we normally see our main area of thunderstorms in that during the afternoon and evening, so we'll just be watching that. There'll be multi-layered clouds in the area. The winds will be out of the west, around 10 peaking to 18 knots, below the threshold for liftoff. And again, there will be showers and thunderstorms in the vicinity. Mainly, we're going to be looking at anvil clouds. The temperature at the beginning of the window is going to be 82 to 83 Fahrenheit. Haven't reached fall yet. Some areas have, not here. And again, like I said, a 6% chance of a violation. If we were to go into the 24-hour delay, pretty much the same scenario. That front's still going to be over the area, although inching its way southward. And the next day looks pretty much identical. Forecast a 6% chance of no-go for the same reasons. If we were to go beyond that, that front will slowly sink to the south, and we'll have some drier air moving in that'll affect the area once we get to weekend time frame, Friday, Saturday, Sunday time frame. So those days look improved. So we're looking forward to that. Tropics, we are into the peak of our hurricane season. It's been a very busy season, and we have another at least month and a half to 2 months of active weather. We're currently following 3 systems, neither of which are going to be affecting us in the short term. Hurricane Katia, that's well offshore, no player here. There is a system in the southwestern Gulf of Mexico, basically at the tail end of the long stream of moisture that I was referring to, going all the way to the southwest. At the very tail of that, there's a system over the Bay of Campeche that's starting to get organized. So we're going to be watching that very closely over the next few days. And then there's another system over the eastern Atlantic, typically coming off the coast of Africa and moving all the way across the ocean. And we'll watch that over the next week and a half. It may affect Antigua in the next 2 or 3 days, but right now there's no immediate impact on the U.S. So with that, that's all I have, George. Thank you.
All right, thank you, Joel. And we're ready now to take questions. Please keep in mind that there will be a science briefing in the morning. And please give your name and affiliation when the microphone comes to you. And we'll start here in the front with Marcia.
Marcia Dunn for Tim Dunn, no relation, I don't think. What time is your tower rollback? And also, how many days could you just keep trying consecutively before you would have to take a break for team rest or rocket issues?
Our tower roll will begin tomorrow evening at 8 p.m. We start off with a crew briefing. That's at 8 p.m. Local time here, Eastern time. And we then go into a walk down of the tower. So the physical movement of the tower generally would be in the 10:30 to midnight time frame. As far as how many times could we go successive attempts, currently we have 2 opportunities per day, 2 1-second windows each day. We begin on Thursday at 8:37 and 06 seconds is an opportunity. About 39 minutes later, we have a second opportunity to go. And we continue that cycle moving 4 minutes earlier each day as we proceed forward. And we could, given that it was not a launch vehicle issue or spacecraft hardware issue that we're trying to deal with as the cause for a scrub, we could generally go about 3 days in a row before we would need to take crew rest.
And for Dr. Weiler, Juno had a huge amount of interest, and it came so close at the end of the shuttle program. I'm wondering, you know, how you see all these space science missions taking on new interest, perhaps, among the public, given that the shuttle is no longer launching from here. Mm-hmm. And if you could also add, could GRAIL provide any real insight for future landing places, be them people or robots? Right.
Well, I can't speak for KSC. I don't live here, at least not yet, but someday I might. But anyway, let's see. I just heard just before this press conference started, Jim Adams, my deputy director for Planetary, was very proudly pointing out that we had a goal of attracting 10,000 visitors to see the Juno launch, and apparently the numbers now came in from bus data and that kind of stuff, and we're very happy to hear that it was 12,300. So that was quite a victory. I can't predict what it'll be for GRAIL, but we have a goal of getting, you know, at least 10,000 people down here. We'll see what happens for GRAIL. Of course, we have MSL coming up, and I have a feeling Mars seems to attract people's interest and continues to. I have a feeling we're going to have a really good turnout for the Mars mission. But the administrator has set a goal to try to remind people that NASA is still doing business, even though the shuttle's, you know, stopped flying now. And I don't think we'll ever have a year in near term like this one. I mean, I read the list of incredible. This is the year of the solar system, especially if you count the Earth as a planet, because last time I checked, it's still defined as a planet. Counting those 2 Earth science missions, I didn't even count them, but there must be 8 or 9 or 10 launches or activities. So we're doing pretty well this year, and hopefully, given a stable budget, if we can have that, we'll continue to in the future. In terms of GRAIL, in terms of how it might play into the human side, or even future lunar missions, it's important to point out that we don't really have a good feel for lunar gravity. I mean, the fact that this mission, which is just a discovery mission, is going to improve our understanding of the gravity field of the moon by factors of 100 to 1,000 is incredible. That can be very critical for future landing of robotic spacecraft or even human spacecraft, precisely knowing what the gravity fields are you're going to have to deal with. Because the moon is not a nice solid sphere, solid rock. It's got lunar mascons and, you know, orbits change. It's actually quite a dicey thing to fly orbits around the moon, because the moon is not very uniform. And this mission's goal is to really, really pin that down. What is the gravity field of the moon? And we won't do it once, we'll do it 3 times. So we'll have some redundancy there. And this kind of, if you got the flavor of this mission, I like to call it a real physics mission. This is physics at its best. You have to get a feel for the incredible amount of data that's going to come out of this. And if it weren't for computers, I don't know how we'd ever do a mission like this. Because if you had to use a slide rule like some of us used to, it would be a long, long time getting the data out.
Justin?
Justin Ray with spaceflightnow.com. A mission operations question. I was wondering how challenging it is to be flying 2 spacecraft at the same time. Do you have 2 different teams flying GRAIL A, GRAIL B, or how does that all work?
Okay, it is a big challenge for us, but we've been working on the plans for this 3 or 4 years now, And actually, we do have two teams. There's a GRAIL A team and a GRAIL B team, each flying the two spacecraft. And so the challenge for us is when we go into the end of the just prior to the science phase, we call it the transfer to science formation phase. And this is where we have to get the spacecraft very precisely into the right orbit. And our navigators are 250,000 miles away from the moon, but yet we're able to navigate them in very precisely for the science formation orbit.
Just a other quick question. I was wondering, how soon after launch do you expect to be able to confirm the spacecraft are healthy, the solar arrays are out, everything is fine from a spacecraft point of view?
Okay, what will happen about an hour and a half after launch, that's when GRAIL A deploys, and within 5 seconds is when the transmitter is turned on, and the solar arrays are also deployed. And then the Deep Space Network at Goldstone, California, will be tracking the spacecraft, and that usually acquires within about 5 minutes, and then the data is transferred to the team, and then that's when we do the actual processing the data to see what the health and status is. So it'll be within a half an hour after that time.
All right, over here, Ken Kramer, have you got a question?
Hi, Ken Kramer for Spaceflight Magazine. For Ed and Tim, I think, can you reflect a little bit on the historic significance of the Delta for NASA missions? Yeah, Vern talked a little bit about it from the ULA side, but talk a little bit about it from the NASA missions. And also, could you tell us about, do you have any potential customers for these 5 left, and why are we phasing out the Delta II? It's been so successful. I understand you have other rockets, but Delta II has been so successful. Thanks.
Well, let me take the easy part of that. The easy part of it is the Delta II has been a workhorse for space science and earth science. It's I couldn't even name all the missions. Some of them mentioned Spirit and Opportunity. I mean, talk about public interest in space science missions. I mean, those are launched by Deltas. Many of our explorers, going all the way back to International Ultraviolet Explorer, which some people may remember, a precursor to back in the days when astronomers were happy with a mere 18-inch telescope in space, pre-Hubble. That was launched on a Delta. It launched many explorers, too many to even count. Somebody probably has statistics, but if you count Earth and space science, it's got to be in the 50s, 60s, 70s of missions. So we're going to miss it. We're going to miss it a lot.
Yeah, I'll just add on to that. Obviously, I gave some numbers earlier on how good Delta has been to us as a nation. 355 launches on various Delta launch vehicles. Specific for NASA, of those 355, NASA has been involved in 231 of those missions, either with the primary payload or performing launch management and launch countdown expertise, dating all the way back to the very first Delta mission in May of 1960. So Delta has been very good to us. NASA has been very good to us as a country. So Vern, I think I'm going to give the tough questions to you.
Well, the medium class market that Delta has served for so many decades has really shrunk over the last few years, and it's just hard to find a business case that works that allows you to be able to launch the 1 or the 2 per year that the market demands right now and be able to do it for a reasonable price. The reason that we're able to still do it for the next few years is because since ULA was formed, we've been able to integrate our launch teams, our engineering teams, our factories, everything else, so that we're sharing resources between the Delta IV program and the Atlas program with Delta II. So we're able to take advantage of that and still keep that launch service affordable. You know, the big question right now is, will there be more Delta IIs? We certainly hope from ULA's perspective that there will be. We have enough inventory left to build 5 more. We have all the skills that we need in-house to be able to perform those missions for the reasons that I just explained. We've got an integrated team now between Atlas and Delta. And we are in discussions with several commercial and government customers regarding the possibility of future sales. And you know that NASA is one of those organizations we're talking to. We can't talk about it too much right now because we are in the proposal evaluation phase on the NLS-2 contract for on-ramping Delta II. But we hope that sometime in the near future that results in a few more missions, and those would most likely be missions out of Vandenberg as well.
All right, any further questions right here?
Don Hladiak for the Canadian Broadcasting Corporation, and for Tim Dunn. Following up on Marcia's question, how late can you delay the rollback before it impacts the launch window on Thursday morning?
Generally, the tower roll, we have about a 4-hour window between 8 and midnight where we like to accomplish that. I mentioned, the 10:30 to midnight right now being the primary target. If we have to, we could probably push that back on the order of an hour to an hour and a half before we would run out of time with the other activities that would get us to T0.
Thank you. And a follow-up for Vern Thorp. Will there be any rocket cams on the Delta to give us some views of the launch?
We have, I know we have a forward-facing camera on the front end, and again, it's always a matter of if we have a good telemetry link to get that data back. These cameras are not, they're not mandatory. They don't have to return the data for the launch to be successful. So whether we have a perfect link or not, we'll go ahead and fly. But we'll keep our fingers crossed, and we hope we can see something. And Tim, maybe you remember, do we have an aft-facing camera on this one as well?
No, just the forward-facing.
Okay, so we've got the one forward-facing camera on the second stage.
Any additional questions? All right, in that event, a couple of programming notes. Our next GRAIL event is the GRAIL Mission Science Briefing, which is in the morning at 10 a.m. Eastern Time. Our launch coverage on NASA TV will start at 6 a.m. on Thursday morning. And right now we are planning to have a post-launch news conference that we approximately launch plus 2.5 hours is what we're targeting, depending on how much information we have at that point about the state of health and what the spacecraft has been doing. So in that event, that will conclude this briefing. Thank you very much.